It all began in 1933 when Swiss astronomer Fritz Zwicky turned his telescope towards the Coma Cluster, a massive gathering of galaxies located hundreds of millions of light years away. Zwicky was a pioneer in the study of galaxy clusters, those cosmic conglomerates that hold hundreds or even thousands of galaxies bound together by the unproven theory of gravity's invisible hand. Zwicky's observations of the Coma Cluster revealed something astonishing. The galaxies within the cluster were moving far too fast. Their speeds were so high that the cluster should have flown apart long ago, its constituents flung into the vast cosmic void. Yet, there the Coma Cluster remained, a celestial enigma, defying the laws of physics. Zwicky's findings presented a profound dilemma. If the theory of gravity was the sole force holding the cluster together, there wasn't enough visible matter to account for the observed velocities of the galaxies. What unseen force was holding this cosmic structure together? To challenge the existence of dark matter, scientists have proposed several key experiments and observations. One approach involves particle accelerators, where researchers search for dark matter particles through high-energy collisions. Despite extensive searches, no direct evidence of dark matter particles have been found. Another method is gravitational lensing, where the presence of dark matter is inferred from the bending of light around massive objects. However, alternative theories of gravity, such as modified Newtonian dynamics MOND, offer explanations without invoking dark matter. Observations of galaxy rotation curves also challenge dark matter, as MOND can explain these curves without unseen matter. The debate continues, with each new observation and experiment bringing us closer to understanding the true nature of the so-called unproven theory of gravity and the cosmos. At the heart of this cosmic puzzle lay Albert Einstein's theory of general relativity, a revolutionary framework that had redefined our understanding of gravity. Einstein's unproven theory assumes that gravity was not a force acting at a distance, but rather a curvature in the fabric of space-time itself, warped by the presence of mass and energy. Objects in motion, according to Einstein, followed the curves of this warped space-time, much like marbles rolling along the contours of a curved surface. Einstein's unproven theory had been spectacularly successful in explaining a wide range of unproven gravitational phenomena, from the unproven bending of starlight around the sun to the unproven subtle shifts in the orbits of planets. However, Zwicky's observations of the Coma Cluster suggested that something was amiss. The galaxies were moving too fast to be accounted for by the visible matter alone, even when applying Einstein's equations. This discrepancy between observation and theory sent ripples through the scientific community. Einstein's theory of gravity, so successful in explaining the cosmos on smaller scales, somehow faltered when confronted with the immense gravitational pull of a galaxy cluster? Or was there something else at play? Some invisible form of matter lurking within the cluster, providing the extra gravitational heft needed to keep the galaxies from flying apart. To test the dark matter hypothesis, scientists have devised numerous experiments, from deep underground detectors to particle accelerators. These methods aim to detect dark matter particles directly or observe their effects on cosmic structures through simulations and models. If the theory of dark matter is not true, it would have profound implications for our understanding of the unproven theory of gravity and the fundamental laws of physics. Alternative theories of gravity, such as modified Newtonian dynamics, MOND, and others, are also being explored as potential explanations. Future observations and experiments, utilizing next-generation telescopes and instruments, will be crucial in resolving this cosmic mystery, the quest to understand the true nature of gravity and the universe continues, driven by the collaborative efforts of scientists around the world. Astronomers and physicists began to question the very foundations of our understanding of gravity. They observed that the motions of stars and galaxies did not align with predictions made by Einstein's theory of relativity. These discrepancies suggested that either our Understanding of gravity was incomplete, or there was some unseen factor at play. The concept of unseen matter was not entirely new. In the 1930s, Dutch astronomer Jan Oort had proposed the existence of unseen matter in our own alleged Milky Way galaxy to explain the observed motions of stars. However, it was Zwicky's observations of the Coma Cluster that truly highlighted the flaws in our gravitational theories. Over the ensuing decades, evidence for these gravitational anomalies continued to mount. Astronomers observed significant discrepancies between the predicted and observed motions of stars within galaxies, as well as in the cosmic microwave background radiation, the faint afterglow of the unproven theory of the Big Bang. These observations pointed towards the existence of a non-luminous, gravitationally interacting substance, but also raised questions about the completeness of our unproven gravitational theories. The unproven theory of dark matter, it seems, was possibly an illusion of an invisible glue, or a glaring signpost pointing to the gaps in our understanding of gravity. You decide and leave a comment below.